This is Josh, Minh-Quan, and Carson coming with the second derivative test.
The second derivative test is used to determine the identity of relative extrema in a function, and by that we mean determining if your relative extrema is a maximum or a minimum.
For example, let's take the function f of x equals x to the third plus 3x squared minus 2. So if we want to, using the second derivative test, we're going to figure out if you can, what the relative extrema are, if it's a relative max or a relative min. But first you have to find out where f prime of x is equal to 0, which is where the relative extrema are.
So we're going to take the derivative of that function, which is just using our good old power rule, 3x squared plus 6x. And now we're going to want to find out where our first derivative equals 0, so we know where the extrema are in the first place. So if we set this equal to 0, we're going to get that our extremas are set at x equals -2 and x equals 0.
Saving you guys time. So now let's go over concavity, because that is imperative to know using the second derivative test.
Concavity, woo!
Okay, so the second derivative, when the second derivative is above 0, which means it's positive, that means that it is concave up.
It's going to look a little something like that.
Okay, and then when the second derivative is less than 0, it means that it's concave down.
In concave down, you're going to have your downwards facing you.
Yeah, and one way to think of this is if it's up, it holds water, and if it's concave down, it doesn't hold water. But what's important is that you pay attention to where the relative max and mins are. So concave up has a relative min, but concave down has a relative max.
And we can see that because in up, all your values are going to be higher than this one point, which means that's a minimum. And with down, all your values are going to be lower than the one point you have here, meaning it's a maximum.
Okay, so let's try and apply that concept now. So we have f double prime of x equals 6x plus 6, which you find just by taking the derivative of f prime. So now to start using the second derivative test, we have to find out what the second derivative is at our relative extrema.
And we're going to save you the time and say that f prime of -2, f double prime of -2 in this case is going to be -6. Now that's a negative number, it's less than 0, meaning this is going to be concave down. And when we have something that's concave down that looks like this, we know that the value at the very tippy top is going to be a maximum. What? You don't like my using the word tippy top or using
No,
tippy top?
I'm sorry, it was good.
It's a maximum!
Okay, so that means that f double prime of -2 is a relative max. Okay, and let's try to solve it for the other value. When you find that, you find out that it's 6, which means that it's concave up. Because it's concave up, I think you see that over when we're looking at concavity, that it's really a min.
Woo!
Yep, that's Minh-Quan's name. Okay, so, but for me, what is really helpful when you're thinking of the second derivative test is you have to be thinking about what the graph looks like. So I think of concave up, and I kind of make a U with my hands, and I'm like, okay, it's a relative minimum. And then I do the same thing for concave down, and I'm like, okay, it's a relative max. So now we're going to graph we're going to graph the original function, and we're going to show you what it looks like on the actual graph. Okay, we're going to check our answers now. We graphed out what f of x looks like over on the right. So first let's see if we can find the relative extrema. So we have them at -2 and at 0, which is what we found in there. Now you can kind of see another way to look at it visually. So at -2, it's concave down. But because it's concave down, it's a relative max. And then at x equals 0, it's concave up, so it's a relative min. And now we're going to do a practice problem with Carson that applies the second derivative test.
What's up? It's your boy Carson Alfonzo, just arrived. Alright, so check it out. We got this function right here, f of x equals x to the fourth plus 2 times x to the third. Now what we're going to do right here, we're going to take the derivative of this function, all right? And once we do that, we're going to set it equal to 0, because then guess what? We're going to find and identify the relative extrema, such as the minimums or maximums. All right, so I'll give you a second. Go ahead and do that on your own, and we'll be back with you shortly. All right, peace out. All right, so you should have known how to do that at this point. Basically, I took the derivative of that function, set it equal to 0, and just found the location of the critical points, which are 0 and negative 3 over 2. Now I'm going to take those critical points, and I'm going to plug them into the second derivative of the function, and then we'll begin our second derivative test. All right, so as you can see, I took the second derivative of this function. We have that here. And what I did was I plugged in our critical point values into this equation, as you can see. So over to the right here, I plugged in negative 3 over 2, and I came out with the value of 9, and this is a positive value, and that means that this is a minimum here, and it's concave up, because, you know, a minimum. There we go. And then over to the left here, we plugged in x equals 0, and our value is actually 0, which means we have neither a minimum or a maximum at this point, because it's neither positive or negative. The second derivative isn't positive or negative.
And then we're gonna go ahead and check our answer by looking at what the graph actually looks like and seeing where our relative extremas are. And here we can see that at negative 3, 2, x equals negative 3, 2, we have our relative minimum, just like we tested.
Boom.
And at x equals 0, we have neither a minimum nor a maximum, just like we tested for. So,
Yep, that's the second derivative test. So, yeah.
this is Minh-Quan, and that's Josh.
It's your boy Carson.
So we actually learned something too. So learning's good. Grow your math brain.
Don't kill butterflies.
Oh, there we go.
Are you kidding me?
wait, you